get started with our panel, Harmonious AI. So thank you for being here. Today we'll explore the impact of AI on human emotions, aesthetics, and looking into ways which training AI on emotions can generate human-centered, impactful outcomes and what challenges might exist. So we do have with us three speakers for today, Professor Alexandre Alahi, Dr. Emmanuel Senft, and Dr. Kirell Benzi. Will start first with a presentation from Professor Alexandre Alahi, who is leading the Visual Intelligence for Transportation Laboratory at EPFL, and is also recognized as one of the top 100 most influential scholars in computer vision over the past decade. So thank you.
Is this working? Sure, it's for the online people. Oh, good. Yes, so I'm going to talk about AI, obviously. Our domain of application in the lab is transportation. It's how to develop the AI of autonomous mobility, safe driving cars, delivery robots. But today, I wanted to also go beyond transportation and show you that potentially the same AI can impact our built environment, our architecture, can impact our space, our cyber physical. So let's start with the AI of a self-driving car. This is a self-driving car navigating the space, and what the AI is supposed to do is to assist human, make the same decisions as we do when we drive around. What are these decisions is basically how to turn the car, how to accelerate, brake, and so on, how to avoid collision. Let me give you a quick overview of the AI that is currently in the autonomous vehicle, so that we can be on the same page and we can see how we can apply this in the physical world. So first, there is one step, which is the AI must understand the world, must understand the current state of your environment. In other words, it must detect objects. It must detect a pedestrian, the vehicle, the street, the zebra crossing, and so on. And then once you have a machine that can detect all these dynamic content and static, you can plan a path to control the vehicle. In this example, the planning will tell you just continue your way till the zebra crossing and you're good. For decades, companies really tried to solve the detection problem. It was a huge challenge because you have to use sensors, and these sensors are not necessarily very robust to different lighting conditions, different environment. It's not that easy to develop the AI to just do detection. But since about now 10 years ago, we have this new method called deep learning based on neural network. Everybody is talking about it, and things started to work. And that's why you hear the word AI in the news every day now. And you might be annoyed by it now because it's too much of AI, AI, AI. Because there's this new tool that suddenly is able to solve tasks that it was very difficult for us to write a recipe, such as how can we decide if an image of a pedestrian is a pedestrian. But then is this it? So then there was a huge excitement. We were able to do detection, and billions of money were invested in companies or in startups to do autonomous vehicle, but we still don't see any autonomous vehicle. Elon Musk is claiming every year that this is happening, but it has not happened yet. And the reason is that there is another step that is missing in their view, which was to better predict what will happen next. And we like to refer to it as basically being able to better forecast human behavior. In this example, you saw this pedestrian, and it started to cross the street. We as human driver, without being able to predict that, but the machine Without the forecasting, we would have not been able to do that. So that's what we need to develop in research to be able to make autonomous vehicle a reality, a safe reality, to be able to also predict how the environment will change. Now, if you have these 3 pillars, you want to also rethink how you want to do detection, because you want to better predict. Maybe just putting a bounding box around the pedestrian is not good enough. You might want to perceive much more than just the occupancy of a pedestrian. For instance, you want to be able to detect the focus of attention. Where am I looking at? Because this will tell the system where I might want to go, my body posture, my body language. Am I raising my hand? If I raise my hand, it's communicating something. All these things needs to be solved automatically to be able to better predict. Then, if you combine all these pillars, we have a new type of AI that we call a socially aware AI. An AI that understands humans, an AI that is able to understand social interaction. And in fact, I like the title of this section. For me, Harmonious AI is socially aware AI. Is an AI that will seamlessly coexist with us human and assist us. And so this is the AI behind an autonomous vehicle. But now you can use exactly the same technology in this room, in your home, in your office, in your grocery store, whatever you want. So the way it works, we will put a camera in this environment. A camera is a sensor. We will solve the first step of perception, detecting the state of the environment, how we humans actually use the space, where are we, what are we doing, and then we can also predict potentially how we want to use the space, where are we going to go, when are we going to leave, when are we going to enter, and then we can modify the environment, the space. We can control the space. What are the very common way of controlling the space? It can be its energy, the heat. We can control your thermal comfort. We can control the air quality, because the air quality depends on how you use the space. We can even think of controlling your furnitures, how to move these chairs. Right now, there are so many empty chairs. If an AI system was installed, you could have removed it and you would have much more space. And whenever someone comes, a new chair comes and they sit on it. So the environment, your space, can become dynamic and react to basically us, assist us. So let's look at another example in transportation. This is this small robot that its goal is to do delivery, but the robot needs to navigate this space as human. And it's again extremely challenging. So this is our robot. If we look at its AI, again, the first step is detection. It will detect all these pedestrians, and then it will try to take a path that is physically possible. But all these 3 paths are suggested. It will take the shortest path, but if you take the shortest path, that's not good enough, because the shortest path is suggesting to go through these 2 people who are talking to each other, and it's socially not accepted. It's rude to have someone that goes in between 2 people talking to each other. Or the left one is also not okay, because we know that this person is walking, and if we take this path, we'll have a collision with that person. So there's only one path that is useful. And again, to be able to do that, we need to have our forecasting capability. And if you combine all this, you again have socially aware AI, which understands social interaction, human social interaction. The fact that we like to yield right of way, what is the distance that we like to preserve, to coexist, and how can we simply coexist in a safe and efficient manner. So if you apply this, again, in the built environment, this is exactly the technology that you can use in your mall, in your shops, in your train station, to understand humans and offer a better level of service. For instance, again, with camera installed in public spaces, we can understand how humans use the space. Then we can also predict where they will go and take action on planning. I'm going to share one example, which you might be, that talks to you. Not too far from here, Lausanne train station is under construction right now, right? And we're all annoyed by that, and I apologize because this is because of us. They ask us what will happen if we double the number of commuters in Lausanne by 2030, and how we should change the train station so that they can still offer the right level of service. So to do that, we put cameras. Again, there are sensors. They are absolutely privacy safe, so we're not like extracting identity. We are just detecting the occupancy of humans in the space. This is how it looks like. So we have a lot of sensors in the corridor. And from that, this is the information that we're extracting. It's really the coordinate of pedestrian in the space. And by looking at this data, we can extract some density information, such as is the level of service, is it too crowded in this corridor? And if that's the case, it's not okay. For instance, if you want to transit in the train station to take another train, you should not be affected by traffic. You should have enough time to reach your other train. And they understood that even right now, the corridors are too small. At peak hours, there's too much traffic, so we should rethink the space because of the technology that was able to understand how we use the space. Hence, they convinced the government to spend 1 billion to reconstruct Lausanne train station, but they had to justify it thanks to this technology. What else? Again, we can go even further. We can use the same technology at the city scale. So we can have maybe drones that will monitor the city, understand traffic, and then by understanding traffic, we can predict the origin and destination of all the commuters. And if you're able to do that, you can control the traffic. So you can control traffic lights so that there is no more traffic in your city, so that there is no more congestion. So you save energy, you save carbon, you are much more sustainable, and also time for all your population. Voila. So I think I'm almost my 15 minutes. To summarize, Harmonious AI will allow us to have intelligent agent, but also intelligent spaces. In the context of intelligent agent, the motivation is reduce human error, save us, because nowadays we still have a likelihood to die if we take the roads. There are 1 million people who make mistakes and die per year, so we want to reduce that. But we also want to offer mobility to everyone. There are people that are not allowed to drive, cannot drive, so can we assist them in a cost-effective way and guide them? And in respect to the space, we can save energy, reduce maintenance, improve productivity, comfort, but many more. It's the first time that our environment, our space can become alive and understand how we use it. So we can rethink completely how to reconstruct, how to construct our environment with new applications, new ideas. It's just the beginning. Voilà.
We will now move forward to our next speaker, Dr. Emmanuel Senft, a research scientist at the IDIAP Research Institute, and he is also leading the Human-Centered Robotics and AI group.
All right, so thank you much for the invitation and the introduction. So yes, my name is Emmanuel Senft, and so I'm working at the IDIAP Research Institute, which is actually not too far from here. It's in Martigny Valley, next to the mountains. And actually something which is interesting with this place is that what we're trying to do is to promote quality of life through scientific progress in artificial intelligence. And like the motto of the institute is artificial intelligence for society. So that's why I was very excited when I was invited to come to this symposium, because there's a very big resonance between some of the goals here and the goals of our institute. And my personal research is to look at how we can have harmonious human-robot coexistence in society. because robots can have a lot of opportunities for robots. They could help us in our daily lives, address some of the big challenges that our society is facing. For example, like aging population, we need to provide quality care for aging population. We are starting to have a work shortage in lots of dimensions. We also might be able to benefit from robots for comfort and entertainment. And also something which is very interesting with this exhibition is also robots and also AI can provide new ways of creating. And so all of these are opportunities that are arriving and provided by robots. And actually, we've been talking about these robots helping us for like decades, and we've always been told like, yeah, it's just around the corner, it's coming. And actually, it is actually coming for real now. So that's just two examples that happened to me in the last 6 months. So in one case, I was in China looking to an administrative building, and there was this robot talking to people. So you could come to it, talk to this robot in Chinese, and it would give you some guidance. And if you don't talk Chinese and try to speak to it in English, it would say, oh, sorry, I only speak Chinese, I don't speak English. So there was even already some backup solutions for people who would not be able to interact with the system as designed. And another case in Spain where you have some small robot doing some delivery in a restaurant. So we've been told for decades that robots are coming, and actually they are here now. But there are still lots of challenges to be able to have this harmonious society where robots and humans can coexist. So some of the challenges we've been talking already a bit are social interactions, because humans are social beings. So we are interacting socially with people. There are lots of social signals that we are forwarding. There are social norms that people are expected to follow. And so robotic systems have to be aware of these and to adapt to these social norms. Similarly, robots have to be able to understand humans and communicate. So like lots of challenges in like core robotics, but like manipulation, navigation that we've been seeing a bit already. And another one, which is also like reacting to new situations. Because that's actually one of the key features of human beings when you compare to AI or robotic systems, that humans are highly adaptive. They can react to new situations, improvise, be creative. And currently, AI systems are not there yet. So that's some of the core challenges of robotics as I can identify them. But we also have some risks of robotics, because I've been pretty optimistic so far, saying, hey, we've got all these possibilities. Like one of the risks is replacing humans in variable roles. So like lots, again, I'm coming back to it, humans are social. And when I was talking about aging population, we don't want to live in a world where people are just cared by robots and don't have any human interaction anymore. And so we want to find a way to have a good balance between what sort of roles we give to robots, what sort of roles we give to humans. Because we don't want to end up in this technological dystopia where we don't see any human anymore, we're losing contact with other people. And so finding this right balance is actually a very big challenge. And that's also one of the reasons why there are valuable research now being done in this field of human-robot interaction, where we try to study and design new systems where robots can interact with people. One of these roles is to have like a clearer picture of opportunities and risk for robotics. We want also to be able to develop robot ethically, so design method working with ethicists, with psychologists, with sociologists, to see a bit like how we can have this system being integrated in a good way. We also want to be able to explore new use cases that are not yet possible for industry to explore because the return on investment is too far away. So we have kind of like pioneer role also in research. And finally, there is also a need, especially as we've seen recently with all the progress in AI, for scientists to inform policymaking. And so that's, for me, some of the big roles that we have as researchers towards society. And now I talk a bit about my research. So my group is called the Human-Centered Robotics and AI Group. Like our task is to address some of the roles I was talking before. And the way we work is basically we start by designing a system. So we are working with stakeholders. So for example, in the context of assistive robotics, we might be working with patients with disease or their family or caregivers. We try to understand first the ecosystem in which we'll be deploying robot, and then work with them to find a bit how they want to interact with system. What are their specific needs? What are all the considerations that we have to take into account when we are designing robots? Then once we have a pretty good idea of this design aspect, we can move forward to implement system. So this is work which might happen in the lab, where we are here with our robots programming. We can also develop some interfaces and then go back to design, also to be able to prototype our system to see a bit, have some feedback from the users and from the different stakeholders. And finally, once we have a system, we are ready to evaluate it. So here it could be in lab studies where we are welcoming users to our labs, or in the field study where we are bringing our robotic system to the place where it could be used. So we're talking about elder care facilities, or people's at home, or in the streets, as we've seen in some examples before. And so now I will be contextualizing these three phases on three projects I've been doing in the past. One about assistive robots for the design aspect, one about collaborative robots for the implementation aspect, and a final one about educational robot for the evaluation. So how can we design assistive robots? So we've been working with this elder care facility. We had this robot here. So it's a pretty simple robot. It can move around. It has a camera that can turn, and one arm which can move and like grasp things. So as you can see, it's a very mechanical system, and I wanted to see if older adults would be willing to interact with it, because we have all these pictures in science fiction about humanoid robots with two arms, a face that can have like clear or clearer social signals. But this robot is very different. I wanted to see if we could have this robot interacting with people. And so we went with one of my students in the US. We went to elder care facility, bring this robot to interact with some patients and like some of the residents to see a bit how it could work. And so we had this method in 3 steps, where we first worked with patients or residents to try to design some scenario with them. So, for example, we were asking them, oh, what type of roles do you think the robot could be doing? So you can see the robot can move around, it has an arm, it can grasp things. And so how do you think it could help you in your daily life? And so they were providing us for some information, like, oh yeah, I would like the robot to bring me some water because I tend to be thirsty in the afternoon. Or I would like the robot to bring me the mail because I don't need to have the caregivers bringing me mail. Or some other one told us that they wanted to have what brings them a cup of ice so they could drink their personal drink in the afternoon. And so each person had different needs for robots. And beyond different needs, they had also different ways they wanted robots to interact with them. Some of them wanted the robot to be pretty chatty. They wanted to be able to ask questions to the robot. Some of them said, hey, no, that's just a robot. I don't want to talk to it. It's just here to do a task. Just have it drop the mail there and then leave. And so in this first stage, we're like initially talking with people to see what they could do, and then we're controlling a robot to basically role play the interaction as I said. And through this role play, we're able to refine our design a first time. But here there was one specific thing, was that people, like the residents, always had the scientists around them. And so wanted to have like a second phase that we call the simulated deployment. And what happens there was that we came back a few days later, and here we stayed outside of the field of view of residents, and then we're trying to teleoperate robots, going again the same way as what the residents told us a few days before. So each resident had a list of actions what should do, and we're following it. And one of the things we've been observing here is that actually there was quite a big difference between what people were telling us they wanted, and actually the ways they would interact with robots. For example, we've been seeing quite a few situations where people would be initiating conversation that told us before they don't want to talk to robots, but when it's there, actually people start to talk to it. So they want to engage in this deeper and like more complex interaction with robotic systems. So that was something that only emerged because we're outside of the picture at this point, and so we're able to see it. And finally, the third step was getting some feedback from all the stakeholders. So we went back to the caregivers and told them, hey, we've been talking to some of the residents. They gave us some of these tasks. What do you think? Do you think it's a good task for a robot, or do you think actually a robot should not be doing this because you believe it might not be ideal in terms of like safety for the residents? And so with these cycles, before starting to program anything for the robot, we can have already a good idea about what it can be do, what role it could have, and how people want to interact with it. And something that was very interesting in my perspective was that actually people were very willing to interact with robots. And it was a pretty big difference to a discussion I had with my grandmother a couple of years ago when she told me, oh, I don't want to see a robot. I can do things on my own. I don't want to have like a mechanical system in my place. And then I brought her to the lab just like a few months ago, and she's seen my robot, and she was like, oh, actually, it's pretty nice robot. It's soft when you touch it. And then exposing people to technology can help them to have a better opinion about like what it can do. But we have to go progressively step by step to be able to introduce people to technology and not just force it on them. So that was quite a bit on designing systems. And so I'll go a bit faster on two other projects, one about implementing collaborative robots. So another case where we can have useful robots is manufacturing. For example, in this case, we're working with a Boeing, and we were looking at assistive sanding. So sanding is a process that happens a lot in aircraft manufacturing, which is very technical to do and also very dangerous for workers because they can suffer some injuries after long exposures. And so here, some of the interesting things we were doing in the implementation is trying to find how we can offload the work on the robot, but keeping the worker in control of the system. So it was going through two ways. One was working on designing interfaces, so people could be programming robots in the field without having to write any code or to require any technical capabilities, and also working on interfaces that allow them to correct robot behaviors on the fly. So this was using some haptic systems that allow to feel the forces from the robot. So by implementing systems, taking into account what users can need, we can have more efficient human-robot interaction. And the third case, I'll talk about like how we can evaluate systems. And in this case, it was educational robotics. So we had this situation where we wanted to have robotic tutors to be able to help children in an educational game. So we had a situation where we had a target user, so we had a child, interacting with a robot, with also an adult, like a domain expert. In this case, could be like a psychologist or a teacher, who can observe the target user, so like the child, and also teach the robot on site how to interact with the children. And so this way, by keeping the domain expert in the loop, we can ensure that what the robot does is actually tailored to the current situation. So, but it limits the risk of robot mistakes, and also it allows them to learn under the supervision of a human for later being able to be more autonomous. And so that's a case where on different type of applications, we can have different type of interaction between users and robots. I'll go a bit quickly. And so basically when we think about human-robot interaction, it's actually very similar to some of the exhibition we have next door, because we have interactive system. So robots are inherently interactive. They are not systems that are staying static. People are there, robots are there so people can interact with them. They are cyber-physical, so they are embodiment of AI systems. We interact multimodally with them. We can touch them, we can speak with them, we can see them. It's also a very multidisciplinary field because as an engineer and a scientist, I don't know everything about how a human can and want to interact with robots. So I need to work with doctors, with sociologists, with anthropologists, or with ethicists. And finally, also, as is a big aspect about this empathic connection, because people will start to create bonds to robots, and so we want to manage how people will connect to robots to adapt the expectations to what the system can deliver, and prevent creation of unsafe connection with robotic systems. And just to close, some open challenges that I see for harmonious AI. So working on these empathic interactions and how we can adapt the socialness of the system and the connection that people can build with it, considering the full ecosystem, which for me tended to be mostly like the other people around our human and the main user, but it can also be the physical environment, the buildings, and like how we can connect robotic system to smart buildings, working on the acceptability of robotic systems, how we can have them being accepted in the best roles for them, and finally, how we can have human collaborating with robots in an ethical way. And on this, I'm closing my presentation. Thank you very much.
Thank you very much to Emmanuel. Our final speaker today is Dr. Kirell Benzi. He is a data artist, public speaker, AI researcher with a background in data science from EPFL and teaches data visualization and data art globally at various universities. Thank you.
Yes, hi everyone. So here's a bit of a different presentation. Just thank you very much for the introduction. Something that I should add is I also work at EPFL and actually both labs, Sarah's and Alexandre that you just saw. So I'm in between. This talk is about data art, but I'm also used to working with like big systems and all the engineering that goes with it. So today I would like to talk a bit about art in the age of algorithms, and I wanted to illustrate the first slide with this. I'm sure you've seen this kind of AI generated imagery everywhere now. It's something that is very, very common, and the talk is not about this at all. I just wanted to, I like this art, to be fair, I made this image, and I think it embodies what I think a data artist would be. So you have both your face, and your face is also transformed into a data in a way. But just to illustrate, like maybe show of hand, do you know what data art is? Some of you? So so we have some, so for those who don't know, let me just recap. Basically, the idea is to transform data sets into, I would say, first emotions, and in the second time to also bring the interpretation that you may find in data visualization. So it's very far from the pie charts, I would say, that you see everywhere, and more into something hopefully aesthetic. And through this presentation, I would like to show examples of how I use data art with AI to create some pieces and hopefully have a discussion about it at the end. So just to illustrate quickly, maybe you've seen this piece before because it was at the EPFL at the Lighten Up exhibition. And so let me explain how to interpret something like this. So we see here we have three different objects, I would say, and they are basically about, this piece is called circadian rhythms. So they are about tracking people, about using a watch like this, like a smartwatch, for their sleep patterns and their activity patterns. And the goal here is to visualize about 2 million data points to create this kind of shapes that we can hopefully find cool and also meaningful. So how do you read something like this? So if you see my mouse here, think of this as 8 days. So each ring here is 1 day, and you can think of this as a clock, a 24-hour clock, right? So this is midnight, and usually people go to sleep around midnight. And then, of course, here it's midday, 6 a.m. here and 6 p.m. So think of this as just looking at the clock. And we see we have different colors, right? The colors are driven by the activity that you are doing. So you either static working, you are sleeping, and you have also different shades, right? You have two big different color palettes. For instance, let's talk about the first one here on the left. This one is actually an airplane pilot. So we've asked him to wear the watch and see whether he had the different pattern of activity you have compared to someone here, which is just a 9-to-5 job, and here someone working in a vineyard and doing some manual work. And if you look at a glance, you see that all their sleep patterns that are really on top here are really different. For instance, this pilot here, this is a very funny story. So he went to sleep here. So this is about 11 p.m. And he told me that he was working at, and he had to wake up quite early in the morning, but there was a wedding here. So he was actually waken up by the noise, and he went to sleep 1 hour later. So you can see the blue is just a regular activity. So basically I'm being awoken, and then I have to go back to sleep. And you notice that you also have this light pattern, which are denoting the light sleep. So when you sleep, you have different phases, like light sleep, deep sleep, REM sleep. And the watch, using AI, can actually track this. So that's hopefully it's clear enough. I don't want to go about all the others, but this is about the interpretation and how you transform this, as I said before, around 2 million data points into something that is, this is actually in a video, so it's animated and everything, but it's just I wanted to illustrate the technique here. Quickly, the second one here is very funny. This is 9 to 5 job, but she did 2 like sports session at night, and this is why you see this very big spike in increase in heart rate, and at the same time also the color being more active. So by just looking at this image, you can actually tell a lot about someone, like what are their rhythm, and hence the whole piece. So the goal here is to take something that is from the digital space into something a bit more physical. So throughout the examples, I want to show the difference between just showing something on the screen and, like, as you, hopefully you can imagine, having physically present in the space as well. So this is, for instance, was for a product launch or for a watch. So we had this very big screen and we could shoot some content. And I mean, you know, here when you see all the exhibition, like the fact that you can see, even if it's a large screen, it changes the perception of the whole piece compared to just looking at a very small laptop or on your phone, right? Other example, I think you've seen this. I try to take examples at EPFL. This is was in 2019. Was the Jazz Luminaries installation with Sarah here, and the goal was to visualize and have a immersive experience where you could browse all the archive of the Montreux Jazz Festival. So here, the fact that you all like have a very big installation already changes the perception. But in actuality, the art could be the same and you could see it on your laptop, right? But the fact that it's in the space and changes completely how you feel it. And I think this is what I would like to see more, like culturally, how we can, because there is also AI behind everything. How can we bring this to the space and we get away from the debate about, AI is stealing artists' work online and then we generate NFTs. This has nothing to do with this, right? This is about bringing something in the space. So maybe you've seen this before. The goal here was to basically have this spherical controller and be able to browse this very large network of artists. You could click on an artist and see all the concert associated with each of them. So we're talking 54 years of data and around 40,000 tracks. The whole archive is about 11,000 hours of audio content. So you could stay here for more than a year and like listen to all the concert and you will still be here in a year. So it's very massive as an installation. Now I want to have 2 more examples to show you. And hopefully with this computer, we can actually, instead of showing a video, we can show them live. Let's see if it works. Yeah, I think it should work. Can you see that? Yeah. So this is something that was made and completely driven by AI. So we have this, it's a bit dark, but we have this kind of a cube here. And we basically represent 1,200 fashion brands that have been, that you know. And the goal here was to try to extract all the news article about each of these brands, classify them using 4 different neural networks, and try to see, and you'll see when I click on a point, and visualize, when you look at this brand online, what are the different topics that we talk about? Is it about the partnerships? Is it about the clothes they sell? Is it about the financial results, sustainability? And try to automatically classify and have a visual sense on the perception of this brand online, basically. So let's imagine, I don't know, yeah, Adidas, for instance. So you have this animation, and you see here, if I put my mouse, yes, that the distribution of points is driven by the data. So we see here we have more, Adidas is more into advertisement than I would guess sustainability, which is very, very low here, for instance. Right? For most fashion brands, that's the case. Some of them are, sourced in cotton and everything, but very few of them are really, really green. And yeah, so that was the whole point. So to create this, it was very difficult, to be fair, because we have to extract 10 million data points from Google News, scraping Google News for each brand. So it's about 10,000 per brand. And then when you have news, you don't really know like these topics, right? Is it about a collection, advertisement? So you have to first translate, because you have news in all different languages. So you have to translate everything into English. Then you have to also remove the bad news, because this was for commercial installation. So they don't want you to have a bad content, right? Saying that clothes have been made by, in Vietnam by kids. So you have to remove these. And it's difficult to do this automatically as well. And once you have this, you have to classify. So train another neural network to try to read all this content and put it into here 7 buckets, basically. Once you have this kind of percentage of distribution for all the brands, and then you have to create the visual to represent this. I hope it was clear. This is like the kind of the process of this. And so, yeah, this is, as you can see, a live installation. I mean, still working on a website, but it was also a live installation. It was actually shown in Milan. So it looks like this, because this has the cube form. So this is pretty big. This cube here is around, I'll show you the next image, but just to give you a sense of scale, this weighs 3 tons. 1.5 ton just of LED screens, and 1.5 ton of the structure was, of course, custom made for this event. And you also have this 4 different pillars that you could control with an iPad, so you can type your brand and see how it would move. And yeah, that's me. Not very tall, right? But you can imagine it's pretty massive. So yeah, once again, how to bring some kind of this installation into the physical world and have a hopefully spark a conversation between AI and the rest of the general audience, I would say. And to finish, I would like this is something that I had finished last month, so I'm happy to actually show it for the first time. Once again, it was a big installation for a football company, as you can see. And the goal was to track the movement using AI. So we had this, the camera, exactly what Professor Alahi demonstrated, with this tracking of the skeleton. And basically, you would play here in this capture area for 20 seconds. And we will basically try to assign a touch score, which is basically knowing how well you move with the ball, how fast you go, and all of these metrics that you could imagine, and have a customized basically artwork that would go behind and being controlled for each different player. So yeah, of course, depending on what you would do, it would change. And as you can maybe see, there's some kind of an art gallery. So the theme was to have the ball being dropped, so it's about 4 meters, which is very difficult to do, by the way. Control the ball, go around all the vase and statues, and then go in this touch zone, capture the movement, and have the AI generate for you the final visuals. So it was a big project, and yeah, pretty cool. I also have some of the, I can show you live. I will not play football for sure, but I can show you hopefully what it would look like a bit. So this is the behind the scene. You're not supposed to see all these panels, but just to, it's a bit dark, but to show you. So we got this this kind of structural structure that is being created by the capture. This is just a default, which is supposed to be from the big player. Was made for Jamal Musiala. It's a player that in Bayern Munich, so was here to illustrate the event. And we have, of course, with the camera, you could capture a movement and have basically a personalized version of this here. So yeah, that's it. So I hope that through these examples, you have hopefully a better understanding of how we can bring this kind of, have more other examples. But AI and hopefully spark a conversation which is smoother than just what I've shown before about stealing the other artists' works, by actually shifting the focus from AI art to something data art using AI. And so, yeah, if you have any questions, I'll be happy to answer it. Thank you very much.
Thank you very much to all the speakers. Shall we all join the front for our Q&A session? All right, good. Straight away.
Why is Goethe, making such a face? Did you notice? No? In the background, we had the computer stuff, and Goethe was on purpose, no? Just by accident. Maybe he always looked like this. He never smiled.
No, I do. It's just maybe I was too focused on trying to make my point, but no, I do smile, and it was actually fun, like the experience. Doesn't look like it because maybe I was. I mean, I didn't talk about the it's very stressful to have a live events like this, or you have it's a commercial event and something can fail, and then you cannot fail, right? It's this something that's being filmed and everything. So yeah, maybe remind me of this.
Goethe definitely, and so many cast of others, were right into what they were doing. We are now doing it from a distance, a long distance. We are far away. The computer is between us and the work, absolutely, and think of what is happening there. So that fantastic cultural revolution that we are part of, we should become aware of better, I believe. I'm not defending Goethe. That's old-fashioned, great, but old-fashioned. Ours is low-level, but new-fashioned. Maybe.
Thank you. I think Goethe considered his main contribution to the world which followed was his Farbenlehre. Of course, he was not certainly not angry because of colors, at least. And we have learned that there are 60,000 poems incorporated in artificial intelligence approach, which would be another reason for him to smile.
Thank you for the talk. Me, I have a question that does not involve Goethe for Alexandre Alahi. So my question is, when you develop those self-driving vehicles, you are putting them into our streets that have been designed for driving vehicle by humans. So all of the signalization, all of the way the streets are built is for this paradigm. And then we are bringing something that is outside of this paradigm, self-driving, into it. And what would be, could you develop a little bit the connection in between developing those new tools that are on one system that will, our urban system, that will change by the implementation of those new tools? I don't know if it was quite clear. Is it quite clear?
So maybe if I have to rephrase your question, it's true that if we know that we want self-driving vehicle, we can change the infrastructure, we can change the cities so that our mobility is autonomous. It's possible. So there are also people looking at that, but it's a huge investment, and it will remove the freedom of humans who wanted to still drive in our public space, right? What the community believes, both industry and academy, is we humans succeed to deal with the existing infrastructure. Why not try to learn how humans do it and develop machines that can mimic humans. It turns out that at the end nowadays, this is what AI is doing, and this is where we are impressed by AI, is mimicking humans in many tasks. And why not try to solve it for these navigation tasks? Hence, it can be seamless. So you can still envision people who like to drive to continue their driving, to have cars that are not autonomous. It's also more sustainable, because if you have to remove all these cars from the world, it's not necessarily sustainable. So can we just add a bit of technology so that everybody is happy and we are still taking advantage of our existing resources?
Thank you so much for your talks. I have a question for Kirell Benzi. The first image that you showed us with the clock face visualization and the layers on it, it struck me, it looked like almost a sleepless eye, which I think was kind of interesting given the topic. So I'm just wondering, to what extent do your visualizations, the formal aspects of them, do they embody the ideas that you're trying to communicate?
It's a very good question. So it's very difficult. This one, actually, I would say, is one of the, it's easy to see. It's a clock, it's about time, it's about rhythm. And so the shape was really easy to find. I mean, it's something in the circle. But what about the shape of fashion? Right? It doesn't really mean anything. So I try to make this effort of trying to have a visual content that basically, like, the shape represents the content itself. But it's very difficult. Some topics are really abstract. So I like to go more, and I think it's easier for me also to go in the abstract realm. But for this guy, yes, it was on purpose, this whole eye.
Hi, my question is for Dr. Alahi again. Sorry. No, sorry. For you, sorry. Sorry. I found very interesting when your research on social forecasting. When you there is a gap between a need and a decision making. So when an artificial intelligence makes a read in a room, for example, and sees that by the way people are dressing, the temperature should be a certain temperature. The way the chairs are set, there should be an extended number of chairs. And the decision making of adding those chairs and changing the temperature, that's a human decision. Maybe you do not want to have those extra chairs, and that is so that is something that artificial. I mean, you would need to pre-program this decision making. How can you predict? How a machine can predict what would be on-site decision making that a human would make for this social forecasting, for example?
The social forecasting for mobility is in fact something vital, otherwise you collide. It turns out that we realize that when we move around, we subconsciously predict where people are going to make a decision. It's not even that what they desire or don't desire. If you enter a roundabout, you're predicting if the vehicle will stay in the roundabout or not to make a decision. So you need to always predict in a way that you can make a decision that is safe and coexist. So there is a bit of forecasting that we subconsciously do anyway to make a decision. In the context that you share about maybe AI will make a decision that I don't want, I think this is basically what you said, or like sometimes, in fact, this is the old AI, is when you hard code the decision based on something. No, in fact, the new type of AI is to simulate assistance in a way that human would have done it. And you can still, for instance, allow it or not allow it. In the context of heating, we all have different thermal response with respect to temperature, so we don't like the same temperature. So then you can turn it off or on, but the technology will say it will be able to measure your thermal response, so the temperature of your skin, and adapt it to you. And if you're happy, then we're good. But if you're unhappy, you customize it for your own need. But it can adapt to exactly your custom need. So you have this opportunity to have an assistant that is much smarter, and you still have the freedom to decide if you want to use it. But it's just smarter, it's just more efficient and also more sustainable. I don't know if I answer your question. Yes, but usually all these AI-driven decisions, we still have human behind to decide if they want to use it or not. I mean, only the ones that, okay, it's a no-brainer, maybe we can let the machine go for it, but in many of these applications, at the end, it's just an assistance. It's just to see if, to save us time, to see, I mean, so on. Yeah.
Hi, my question is to all of three. What is the current state of AI? Something that is you're not convinced about for the like deploying AI to the humanity. What is it that what is that argument that you think that you are still not convinced that AI is capable enough?
I'm happy to start at least with robots. One of the big assumptions, actually there are like two main assumptions that were done in the past that are slowly changing. One is that robots should be replacing humans in the same way. Like where you had a human, you should just replace it by a robot, and the robot will be able to do the same work but better. So that was one of the assumptions in the past. Actually, this assumption is very wrong in two ways. First is that you don't want a robot to replace many jobs. You have some types where you might want to replace or not, but some other cases you want to have actually robots augmenting humans. So you have to find how robots can be another tool for humans. And then the other way is even in situations where you have robots replacing humans, in case you don't want, robots should not behave the same way as humans would be behaving. And I'm jumping on like this concept about like imitating humans. Sometimes we don't want AI and robotic systems to imitate humans. We have to find a new way for them to interact in human societies. And so this is like a very complex task, because at least imitating humans, we could say we have a baseline. But like when you want to find this new role and this new way to interact, we don't have a baseline for that. So we have to create it. That's a very non-trivial task.
In my view, AI will never have consciousness and free will.
What can I say now? Okay. Yeah, I would say also beware of the fake benevolent, companies pushing AIs and then making laws to protect, right, the whole world, but they are not protecting. They're just protecting their own interests, because to basically get the license, then you will need many lawyers and a lot of money. So it's just a way for them to stop other people to enter the market, right? But they put some makeup around it and say, no, it's just for your safety. We cannot allow AI to to generate fake news, which is already the case, and you cannot detect it, right? But it's the thing they say, right? So just you have to be aware of this. Always financial interests, but I'm hopeful about the technology to help people. But I think it will be a transition, like a hard transition. It's going to be difficult to adapt because it goes every year. It's something we already like. If you compare like just the ChatGPT now to last year, it's incredible the difference. So what in 5 years, right? So we have to adapt. I think if you don't, you're gonna be a bit left behind for some task, right? Of course, not for a manual task or anything, but for working in computers, not using AI it's actually, I'm less productive now than so I need to use it. Otherwise, if I don't, then someone else will come and take the job because they use AI and they will be 10 times more productive. So you have to adapt, but yeah.
Great. Sorry, I think we might be, one more? Yes.
Now, I had this question also for the previous group of speakers, because we are seeing a magnificent flow of data between inhabiting spaces, permeating objects. So my question is to the three of you, what amount of this flow of data should remain visible to human in a spatial computing environment with a full just dreamed of augmented reality device that might allow humans to see what's happening in real time on the data layer. This also connects to the hybrid objects that you were showing before, and also to the problems that the lady pointed in your previous question. So what would you let visible? Or do you have some predictions about it?
Like, my take on it would be that everything should be visible at some point, or be able to be visible, because you don't want to hide what's happening. But then you don't want to display everything all the time. So you have to be able to define, like, basically let users have some granularity on what they want to see. But I don't think we should start to have AI system hiding data flow, because then you have even more issues about privacy and like what's going on behind the scenes.
I guess, yeah, I don't really understand your question. What do you mean? Like, there are many data, I mean, it depends on the application for me. It depends on what...
At what level the data flow could benefit of being visible? For example, in
you know,
augmented reality.
Yeah, but data, you know, there are like a sequence of 0, 1. What is data? What are you referring to?
The flow of data.
The flow, yeah, exactly. But it depends on the application and use case and the experience you want to communicate. Yes, I mean, there's so right now, you know how much data is in the air? You do? I mean,
which one should I need to know? That was my question.
Exactly, but it depends on society. Right now, there is billions of data in this air right now, communicating wireless. My voice is digitalized right now in the space. It depends. Maybe there is a need for medical purposes, but it's so open to applications and to that. Yeah. So this is my answer.
So not much visible.
No, it's really application specific, right? Sure. It's quite, for instance, right now the ethics is talking a lot about privacy and what you want to communicate, how you want to protect humans' privacy and things like that. What kind of data should you use, not use? But it's depend on the application. And what do you gain from using this, not using it, to communicate, not communicate? So it's so broad that I think it's a case by case that we need to think and decide how we can respect basically humans with respect to whatever we want to offer.
Yeah, I mean, same answer, I would say. I mean, in the future, when we all have AR glasses, then it would be easy to switch between different views and have, I want to see now all the data flow. And I think it would be useful to communicate, to explain, because if it seems like magic, then you start asking questions. So it's good that at least maybe you have a sense of the data being exchanged for a specific application, I would say. But I would not put you know, LED strips everywhere. It really depends on the concept. But when we have glasses, then it's just a layer, so it would be very easy to turn on and off. And yeah, I think it would depend on the application.
I think that's all the time we have today. Thank you very much to our speakers and the very stimulating conversations between the audience as well. All right, thank you.